Okay, so like I said, we looked at graphs to find zeros before, and sometimes we had those decimals where we had to like estimate. Now we're going to find these zeros algebraically, and for a while we're going to see whole number ones. I don't think we'll see any crazy decimal ones. We might see some fractions. So this whole section is solve quadratic equations by factoring. And really we need to talk about three kinds of factoring, and today we're going to cover the first two. So the factored form of a quadratic equation is 0 equals, you might have a coefficient here, but in general, it's like x plus or minus a number, x plus or minus another number, where a is not 0, because otherwise this whole thing would be 0. So in this equation, P and Q represent the x-intercepts of the graph of the related function. Remember, we use this word related function if you set this equal to 0. Okay, so don't let that be too weird. So they give us a lot of stuff here. Really, the thing I want you guys to remember is this product property here, this zero product property. What it says is if you're multiplying two things, so if A times B equals 0, then you know that either A is 0 or B is 0, or both A and B are 0. So the nice thing about the factored form is even though this isn't like an A or a B, it is, right? This whole parenthesis you could consider as like an A, and this whole parenthesis you could consider as a B. So either x minus 2 equals 0 or x plus 4 equals 0, because when you multiply two things, if they equal 0, one of them has to be 0. That's just how 0 works. So we can factor these equations and find where that 0 happens, because wherever that 0 happens is our x-intercept. So I gave you some steps here. You guys know we love this book so much. It focuses on, first of all, we're not just ever going to leave it in factored form. I know in Algebra 1 a lot, we would say either solve the quadratic or we would say factor the quadratic, and you would just stop at factoring. Here you're actually going to solve. So to solve, you need to first set one side of the equation equal to 0, and that's not always done for you. Then you need to factor the trinomial, and like I said, we'll have a couple ways to do that. Use the zero product property to write separate equations. What that means is we're just going to split off into two different possibilities. And then use the properties of equality to isolate the variable, meaning if it's x plus 2, you would subtract 2 from both sides. So let's see our first example here. This is using factor and solve using GCF. Does anyone remember what does GCF stand for? Greatest common factor. Okay, so let's write that one time, and then I'm going to keep abbreviating. Greatest common factor, which for us really just means what's the biggest thing you can pull out of these two parts, because you're going to have something with two parts. So we're going to solve the following by factoring. And when it says check your solution, we're just going to check it by looking at a graph on Desmos. You guys don't have to on your work or anything, but I want you guys to know that's a way you can check your solution. Actually, we could even check it on our calculators. So what is the biggest number that I can pull from 2x squared and 4x? I heard a biggest number and variable because you guys are already ahead of it. You guys said 2x. That divides, that's the biggest thing that divides both this part and this part. If you need to break it down, you can think of what's the biggest number. 2 can divide both of those. And the least amount of x's you see, which in this case is 1x, and it will almost always be 1x. So you can pull out a 2x. So that means I'm going to have a 2x times some parenthesis equals 0. Now, if you need to take a step because you can't see this visually as much, this number here, if you want to actually divide it, here and here, if that helps you to kind of see where that's coming from. What is 2 divided by 2? 1. So you can put the 1 if you want here. You don't have to. And then what's x squared divided by x? X. Because remember, you have your exponent rules. So if you guys don't remember, those exponent rules say that x squared over x to the first is the same as like x to the 2 minus 1, which is where you get that x to the first, just as a recap. So we have a 1x here. And then what's 4x divided by 2x? What's 4 divided by 2? 2, and it's positive. And then the x's would cancel out here or divide to 1. So this was, first of all, step 1 was done for us. So it was set equal to 0. We just did step 2. We factored the trinomial, in this case using greatest common factors. Now we want to use this zero product property. So all that says is that you're going to like basically separate this into two different equations. We'll make this 2x equals 0 and x plus 2 equals 0. Some of you will be able to do this in your head without like drawing the split. That's fine. But let's show our steps anyways. So if 2x equals 0, then you can divide both sides by 2. But you see anything, 0 divided by anything is 0. So we have x equals 0 as one of our solutions. And here we just subtract, 2 from both sides. So we have x equals -2. So on Go Formative, how you can put in your answers is 0, comma, -2. Just list them with a comma. Order doesn't matter. I put it in both ways. But that's it. Are there any questions about part A here? All right, for part B, what is my greatest common factor? What divides both 6x squared and -3x? 3x. Just a hint, oftentimes it is either, it's like this last number usually, or sometimes, or it's the first number. I guess that's the only two things it could be. So if you need to write the step, if you have trouble doing this in your head, you're dividing both sides by 3x. So 6x squared divided by 3x is 2x. It loses 1x, and then 6 divided by 3 is 2. -3 divided by 3 is -1, and then the x's would cancel out. Once you have these two things that are multiplied, you have like a number out here in a parenthesis. This is where we split. So this is that step 3, the zero product property, which says that either the 3x is equal to 0 or the thing it's being multiplied by, this 2x minus 1 is 0. And then we just solve. If you have the coefficient times x, it's always going to end up being x equals 0, because when you divide by anything, that doesn't matter. Here, this is kind of a two-step, and maybe you can do it without doing all the steps, but I'll show them. So we'd add 1 to both sides, so you'd have 2x equals 1. And then you'd divide 2 from both sides. And so you have x equals 1/2. So again, on Go Formative, I would just list 0, comma, 1/2. If you put x equals on like your quiz, or even if you just like on a test, say you just circled that and that, that's totally fine. Just Go Formative. I didn't want to have like a million different answers, so that's why I just list them for Go Formative. But if you just circle them on your like quizzes or even your assignment, totally fine. Same thing. All right, part C. This is only tricky because, again, your book kind of stressed this. This is not set equal to 0, so we've not done this step 1. So what do I need to do to make this equation set equal to 0? Subtract x. You guys got it. I think almost always I'll have you have the 0 on the right side, just to make things easier. So it'd be 12x squared minus -2x minus x is -3x equals 0. What's the biggest number I can pull from 12x squared and -3x? 3x. So if you need to write this out, you can divide by 3x, divide by 3x. So here I'd have 12 divided by 3 is 4. X squared divided by x is x. And then -3x divided by 3x is -1 equals 0. And split these into two answers again. So I have either 3x equals 0 or 4x minus 1 equals 0. So then I'll have x equals 0, because if I divide by 3, that doesn't change anything. If I add 1 here, I would have 4x equals 1. Divide both sides by 4. I'm going to run out of room here, but I have x equals 1/4. So So on go formative, I could just list 0, comma, 1/4. I forgot I told you we were going to check our answers. So really quick, I'll show you how to check them actually on the calculator. Because again, I want you guys to be amazing with these calculators, and it seems like you guys were pretty good for the quiz. So when you're checking, so let's say I'm just checking this equation here. You still have to check with this equal to 0, but instead of equals 0, let this be your y. So what I'm going to type into my y equals is just this 12x squared minus 3x. And then if I don't hit table, say I've just hit this graph, we remember that that graph shows up, and then you can kind of, it's sort of hard to see, but you can scroll in and see, okay, at 0, our x is 0, right, at y equals 0. And then when our x is 1/4 is about 0.25, so it's kind of hard to see that, but our y is 0 there as well. It's really close. You can also see it, well, you can't see this one in the table, but if you zoom in, remember you can zoom, you could change your window. Let's change this to -5 to 5. -5 to 5. You got a little closer and hit your graph, you could scroll and get a little better of an estimate. So you can see that it's about right there, right? I'm going through this a little quickly because we'll see this multiple times. But that's one way you can check. You can also check by typing these in on Desmos, but obviously Desmos you couldn't check with a quiz. So just in case you have time or you're not sure about your answer, you can always check those answers. Questions about greatest common factor? Okay, I have one more thing to show you. Example 2. Factor and solve a trinomial. Oh, my thing froze. Hold on. So factor and solve a trinomial. I always sort of say this is like the normal factoring. I don't know how else to think of it. Normal factoring. And this is where your a is equal to 1, meaning there's no coefficient in front of x squared. You guys remember the Lizzie British method? Sort of, maybe the slide and divide. Factor by grouping. We'll do that tomorrow. That's this example where your a is not necessarily 1. It makes things a lot harder. Not really, but I mean, it has more steps. So here we're still following those same 4 steps as the first page, but now there's not a greatest common factor. Okay, so I can't pull a number and an x from all 3 of these. The big thing to look for here is that, first of all, there's a part that doesn't have an x. So if both of your things have x's and there's only like 2 terms, that's a greatest common factor. If you have a straight up trinomial, 3 parts, this is going to be our normal factor. So I don't know how you guys have done this in the past. This is how I always do it. First of all, we make sure it's equal to 0. Check, done. And then I always do this rule where, so how these factor is that whatever multiplies to this number will add to this number. You guys remember this? So what multiplies to C, which is our last number, and adds to B. So I try and be pretty organized about this. I don't know if you guys have seen, but I'm a little bit type A in this classroom. So I will list all my factors of positive 10. There's not a ton of factors here. My factors of positive 10 are 1 and 10, 2 and 5. There are also negative factors, but I don't technically need to list those there because this is a positive number. And so then if I check, okay, well, 1 times 10 is definitely 10, but 1 plus 10 is 11. So that one's out. 2 plus 5, though, is 7. So these are my factors. So once you find your 2 factors that multiply to this number and add to this number, this is where you do that split where you're going to say, okay, I'm going to have these multiply to 0. It'll always be just like the x, not an x squared, but an x. And then if this was a positive 2, it'd be plus 2. Positive 5 plus 5. You can always check this by multiplying it back out. You could FOIL. You could use your box method, distribution. But do you guys remember doing something like that for factoring? No. No? Okay, so we'll practice this a lot. So once you have these 2 factored, again, the 0 product property says either this whole thing is 0 or this whole thing is 0. So you can split this off. So we can say x plus 2 equals 0, or x plus 5 equals 0. And some of you, again, will be able to really quickly do this without even splitting off. If it's x plus 2 equals 0, subtract 2 from both sides, and you get that x is negative 2. And if it's x plus 5 equals 0, you subtract 5 from both sides, and you get x equals negative 5. So on Go Formative, you could just then put in negative 2 comma negative 5. You could check this algebraically. You could check this graphically. Graphically, yeah. So if you plugged in negative 2 up here, it'd be negative 2 squared is positive 4. 7 times negative 2 is negative 14. So positive 4 plus negative 14 is negative 10. Negative 10 plus 10 is 0. So you could check it in algebraically. Or, like I said, you can check it with your calculator. This one will be a little easier to see. If I type in x squared plus 7x plus 10, go to your graph. This one you can totally just scroll over. You can see that blue line happens there at negative 5. Hits the x-axis, and over here it hits at negative 2, which is not going to jump right to it, I don't think. No, it kind of passes over it, but negative 2. Okay, let's keep looking at these. So again, I checked to make sure this is equal to 0. It is equal to 0. So then I'm going to look for all the numbers that multiply to positive 24 but add to negative 11. So now I have to add to a negative but multiply to a positive. How is that possible? If one's positive and one's negative, wouldn't it multiply to a negative? Oh, yes, sorry. Yes. Okay, so you're on the right track though. You have to think about that. If it's gonna add to a positive and multiply to a positive, I said that backwards, then it'd be a positive and a positive. But if it multiplies to a positive and adds to a negative, they both have to be negative. So you can start running through. 24 divided by 1, negative 1, and negative 24. That multiplies to positive 24. Okay, it's ending with an even number, so I know it's divisible by 2. So it'd be negative 2 and what? 12, so negative 12. What's another factor, my next one? Negative 3 and negative 8. What's next? Yeah, negative 4 and negative 6. Do I have to keep going? No, because if I keep going, I just have the other side here, right? So you can kind of see where to stop. If you're really not sure about how these factor, you can always just like go through the division. You do 24 divided by 2, 24 divided by 3, 24 divided by 4, 24 divided by 5. If it's a decimal, it's not divisible, that kind of thing. So which of these two add to negative 11? Which one? 3 and 8. So when I factor, I'll have my x's here. Now, since they're both negative, it's going to be x minus 3 and x minus 8. Then I'm going to separate them, and maybe you can already see that the answer will be positive 3 and positive 8. But if you need to do this step, and tomorrow we will have to, be x minus 3 equals 0, x minus 8 equals 0. I would add 3 to both sides here. So I get x equals 3. And here I would add 8 to both sides. So I get x equals 8. So on Go Formative, I would just list 3 comma 8. Not to be confused with an ordered pair, just listing my x's. We see in this pattern how this works? All right, this one. Am I good to write my factors of negative 9? No. Why? 18. Yeah, you have to, and the book is like, it really stresses this. You have to make this 0 first. So I'm going to subtract 18 from both sides. So then I'll have x squared minus 6x minus 27, because negative 9 minus 18 is negative 27, equals 0. So now I'm going to list all my factors of negative 27. So this time it multiplies to a negative and it adds to a negative. So I'm going to list -1 and +27. What else is there? -2 does not divide it. How about -9 or -3 and 9? This is close. What's -3 plus 9? +6. So what must it be? Yeah, so how about +3 and -9? You can also see if it multiplies to a negative but adds to a negative, this side, if you're always listing your bigger numbers here, should be negative. But I will let you guys find those patterns as you do these. So I will have my 2 sets of parentheses. Since the 3 is positive, it'll be x plus 3. And since the 9 is negative, it'll be x minus 9. I'm going to split these off into my 2 solutions using the zero product property, which again, maybe some of you can jump right away to the answers. So here I would subtract 3 from both sides. I'd have x equals -3. And here I would add 9 to both sides, and I'd have x equals 9. I'm going to assume by our wrestling that we are feeling comfortable with this. We're ready to practice it? Okay, let's do it. Oh, it froze. Sorry, hold on. There we go.